Hi everyone. So we're going to talk today about solving quadratic inequalities in two variables. Yesterday we talked about solving these types of inequalities in one variable. So just like when we talked about solving linear inequalities in two variables, we are going to have to show our solutions graphically on a coordinate plane because our solutions are going to be a set of coordinate points. They won't just be x values, they will be x and y values because these inequalities include two variables, okay? So when we're solving these graphically, what we want to do is graph the corresponding function. In this case, in the first case, it would be y equals x minus 4 all squared minus 2. Now, luckily, this one is fairly straightforward to graph because it's already in vertex form. Okay, so if it's in vertex form, I am just going to draw a grid in here. And my P and Q value, remember vertex form is y equals a times x minus p squared plus q. Okay, so my P value is 4 and my Q value is negative 2. So that is where my vertex will be at, oh, whoops, my bad, sorry. I made it 3. Here we go. I made it 3, negative 2. Don't want to do that. 4, negative 2. There we go, that's better. Okay, so there's my vertex. And the a value in this case is 1. So this is going to look like y equals x squared, except instead of the vertex being at 0, 0, it's now at this point 4, negative 2. So what I'm going to do is I'm going to make a little table of values for y equals x squared, just so that I can figure out what points do I have to plot from this new quote-unquote origin of 4, negative 2. So I like to use these ones. These ones were the ones that I used when we were doing quadratic functions. So when x is negative 2, y is 4, because negative 2 all squared is positive 4. This one would be 1, 0, 1, and 4. Okay, so starting from this point over here, I'm going to plot the point negative 2, 4. So I've got to go 2 to the left and up 1, 2, 3, 4. So there's my point. Okay, and I'm going to go 1 to the left and 1 up. There's the point negative 1, 1. And then 1, here's 0, 0. 1 to the right, 1 up, and 2 to the right, and 4 up. Okay, now this is a greater than inequality, so my graph has to be dotted, not solid. There we go. And basically I have to shade either above this curve or below this curve. So if you know that it's greater than, typically that's above the curve, and if it's less than, that's going to be below the curve. But you could also take a test point, okay? The easiest test point to take is 0, 0. The only time you wouldn't test 0, 0 if 0, 0 is actually on the curve. Okay, so let's test 0, 0. I'm going to make the prediction that we have to shade above because y is greater than this function. But let's just test 0, 0. So I'm going to go back to my inequality and I want to know, is 0 greater than 0 minus 4 squared minus 2? And that's going to give me 0 greater than negative 4 squared is 16. Whoops, 16 minus 2, sorry. And that's false. That's 0 greater than 14. Okay, this is false. So we need to shade the other section. Okay, so I'm just going to shade here. And then I'm done. That's all I need to do. Okay, now let's look at another one. For this inequality, y is less than or equal to negative x squared plus 2x plus 4. If we want to graph this, first we have to convert it into vertex form because it's not currently in vertex form. Okay, so this needs to be in vertex form. And the process that we go through to get it into vertex form is completing the square. So that's what we're going to do. Okay. Now I'm just going to start with the corresponding function, and then we'll worry about the inequality after we sort of take test points, etc. Okay, so I'm just going to start with this. Y equals negative x squared plus 2x plus 4. And the first thing I need to do is factor out the a value from the first two terms. And the a value right now is negative 1. So I'm going to take that out, and I'm going to be left with x squared and then minus 2x plus 4. Okay, and now what I have to do is I have to take half the value of the coefficient of x, square that, and add and subtract it inside the bracket. So half the value of negative 2 is negative 1. When I square it, I get positive 1. So I'm going to add positive 1 and subtract 1 inside the bracket. Okay, and now I'm actually going to take that last term outside of the bracket, and I have to make sure I multiply it by this a value that I factored out when I do so. So it's going to be minus 1 times negative 1 plus 4 when I do that. And now I can just simplify this a bit. So I'll get y equals negative 1 times this perfect square trinomial is now x minus 1 squared. And then negative 1 times negative 1 is positive 1 plus 4 is plus 5. Okay, so if I graph this, this is a parabola with a vertex at 1, 5. Okay, so there's 1, 5. And the a value is negative 1. So this is going to look like y equals negative x squared. Okay, but it's been translated from the origin up to 1, 5. So if I take a table of values of y equals negative x squared.
Mr. Paris, can you call the main office, please, Mr. Paris?
Sorry for that interruption. And maybe I'll take those same x values that I did before. Okay, well, x squared, negative 2 squared is 4. So negative x squared is going to be negative 4. Okay, and these are all going to be the negative values of what they were when we did this a minute ago. Okay, so now I have to plot these points, instead of starting at 0, 0, starting at 1, 5. Okay, so I'm going to go negative 2, 4. So negative 2, negative 4 rather. So I'm going to go 2 to the left and 4 down. 1, 2, 3, 4. So here's 1 point.
Wyatt Damaris, can you come to the main office, please? Wyatt Damaris.
Negative 1, negative 1. So 1 to the left, 1 down. 1 to the right, 1 down. And 2 to the right, 4 down. Okay. Now, this inequality was y is less than or equal to this function. Because it's less than or equal to, this is going to be a solid line or solid curve, I should say, I guess. It's not really a line, it's a curve instead of dotted. Okay, now, because it's less than, I'm going to predict that we're going to have to shade below the curve, but again, you could take a test point. So again, if we test 0, 0, okay, now we should test the original inequality, not the one where we completed the square, because if we made a mistake in completing the square, then our mistake won't show up in that version. So I'm going to test the original, and so I'll put is 0 less than or equal to negative 0 squared plus 2 times 0 plus 4, and this is going to become is 0 less than or equal to basically 0 plus 4, and this is true. So that means we shade this section. and then we're done. All right. So one more problem. This is an application-like problem. A satellite dish is 60 centimeters in diameter and 20 centimeters deep. The dish has a parabolic cross-section. Determine an inequality that shows the region from which the dish can receive a signal. Okay, so let's draw a cross-section of this thing. So a satellite dish basically looks like this. They're kind of obsolete now, but they used to be stuck to roofs back in the day so you could get extra TV channels and whatnot. So a cross-section of this thing will look like this, essentially. And we're told that this is parabolic, okay? What we know about this is that the diameter is 60, and this depth is 20, okay? Now, we need to come up with an inequality that shows which section of this dish, and remember, although the dish ends here, it can sort of receive signals from anywhere in this direction. So this is going to kind of continue upwards, okay? So it's going to be anywhere inside here, essentially, that this thing can receive signals. We want an inequality that shows this region, okay? Now, a quadratic function takes the form y equals a times x minus p squared plus q. That's in vertex form. And we don't have a coordinate grid on here yet. So we can put one on wherever we want. And we can make the origin go wherever we want. Okay? We could make the origin go at this point if we wanted to. Or we could make it go at this point if we wanted to. Or this point. Or we could make the origin up here if we wanted to. Okay? But when you're doing this, choose a point that's easiest in terms of this equation. If we made the origin at the vertex, if that was the origin, if that was the point 0, 0, then P is 0 and Q is 0. And then this equation becomes y equals ax squared. And that's kind of a nicer equation to deal with. So that's where I'm going to choose to put it. Okay? Now we can actually write in some coordinate points. If this is 0, then this over here is 30. Because the entire thing is 60, this represents half the distance from one side to the other. So this is 30, and this would be negative 30. Okay? This would be at a height of 20. So this coordinate point is 30, 20, and this coordinate point is negative 30, 20. Okay? If we want to actually figure out the a value, we can plug in a point for xy to get a. And we have 2 points that are available to us, 30, 20 and negative 30, 20, and either of those will work. So that's what we're going to do, okay? So we have y equals ax squared. Let's maybe plug in 30, 20. So y is 20, a times 30 squared, okay? So that's going to become 20 equals a times 900, whoops. Okay, or a, if we divide both sides by 900, a equals 20 over 900, which reduces to 1 over 45. Okay, so the corresponding function is y equals 1 over 45 x squared. Okay, the inequality, because we're shading above the curve, will be y is greater than or equal to 1 over 45x squared. Okay, so that's all I have for you today, but I will see you guys soon.